Okay. Perfect. Welcome everybody to this last session today. I really appreciate that you have the energy to join me. I would like to make this, well, I try my best and do my best to make this entertaining, not too long, also in the interest of time at the end. So if you have any questions, even in this session, I have no problem with it at all. Just interrupt me, throw it out to me. Let's make it as interactive as possible, if you like to, at that point of the day. So I'm going to talk a little bit about predictive analytics. I heard this was a huge topic in a lot of sessions today. So RapidMiner is a predictive analytics firm, so yeah, that's good. We can work on Hadoop, which is another thing, together with our partner Hadoop. Zoltan, the CEO of Hadoop, sitting right here in front. So I would like to give you a little bit of insights, what we are doing in a sort of different way and how, or what that means in practice. And we will talk about time a lot. I will start talking about time right away, and well, by making the difference between traditional BI and predictive stuff. That's probably well known to everybody, but still I would like to do this for the few people here who might not have been as much exposure to predictive analytics in the past. There will be time in the sense of being more efficient in your work. And then finally, there will be lots of talk about time in the sense of how much time can you save by implementing predictive analytics right in your Hadoop cluster. So, well, let's start. And let's start with a picture. And what I would like to give you is this feeling how most companies are led as of today. Most companies drive, or most people within companies, leadership teams, drive companies like that. I'm sitting in the car, I have the hand at my steering wheel, and I drive like that. What I'm doing here, well, I have to look out here, better I should do this down here. What am I doing here? Well, it's very simple. What I'm doing is I'm driving my car, but I'm not looking through the windscreen at all. I'm driving my car by looking constantly into the rear view mirror. And that's crazy, really, guys. I mean that. Not sure how many people have been in this session, have been together with me in the session before, well, this one, when Oscar has been talking. Oscar from Luminar described how they are solving some problems for got milk, about the prediction, basically, or the fact how much milk is consumed. And they found out that there's a specific segment where less milk is consumed or has been consumed in the last year. Well, if I'm a milk producer, I would say, fine, thanks for letting me know. We sell less milk than before, or we have sold less milk in the last year than the previous years. Great. Thank you. It's too late. Guys, it's too late. The milk, we are selling less milk day after day. It's unbelievable. I want to know something like that in advance. I want to stop driving a car like that. Oh yeah, we are selling less milk. Okay, that's a problem. It's crazy. We have to stop doing that. So yeah, people found out. Okay, that's good. People can learn. So the next step then is, okay, let's start looking through the windscreen. At least that. So what happened, what just have happened is really, now I'm able to look at the current data. Terms like real-time analytics, terms like data discovery are important here. Tools like Tableau, Click, they all allow business users actually to create their dashboards on their own, which is great. It reduces the time to insight. Cool. I just learned from Oscar again, is he still here? I don't know. Oscar here on the milk thing, I just heard that they reduced the execution time for their data integration and analytics from 3 days to 3 hours, thanks to Hadoop. Great. So now I have insights about how much milk I didn't sell last year in 3 hours instead of 3 days. And I'm getting a nice pie chart, or bar chart, or whatever, telling me what has happened in the past. Yeah, it's sort of real time. I'm starting looking through my windscreen. I know what's happening around me. But, well, okay, now I'm driving my car. But what makes us human beings so amazing is actually we can anticipate what's happening next. I'm too fast for this next curve. The road is wet. I should slow down. We can anticipate what's happening next. We are amazing. Human beings are. If I would sit in this car, I would like the car is doing this for me. If I would think about a self-driving car, I for sure want my car to anticipate things like I do this as a human being. In our example here, that would mean I would like to have a car which is warning me already, look out, there's a curve, and behind the next curve there's an accident, or slow down because the road is red, whatever, you do something. And by the way, cars are pretty smart. So we are driving smart cars, but we are driving our businesses like in the last century. Oh my gosh. So that's how it is, and that's what I said. We are talking about time. I would like to know what's going to happen, and I would like to really base my decisions on that. You could call this predictive intelligence, if you like. So instead of just the old data, you make predictions. 2 years ago, we lost 20% of our customers. Last year, it was 25, so I'm going to predict it's 30 now. Good, but not good enough. The point is, how are those predictions created? You could look at the aggregated data and look at the trends. And again, Oscar, where are you? I've seen exactly that. You guys did that. You aggregated the data from the past, and you came up with some insights based on some trend analysis on those aggregations. Not bad. But there's a different possibility, and that's the big difference between predictive analytics and everything else analytics. The big difference is that predictive analytics models, they make the prediction for every single case. They will do the prediction for every single customer. This customer is going to stop drinking milk. This customer is never buying milk for their children again. This customer is, I don't know, is drinking almond milk from now. You're doing those predictions for every single customer. And if you do that, you can still aggregate those millions of micro predictions and come up with the overall picture, with the predictive insight, with the predictive intelligence. But keep in mind, you produce this insight by doing those millions of micro predictions. And that is important. Why? Because I'm 100% sure that the value of those millions of micro predictions is much higher than the value of whatever predictive insight. If I'm going to see, oh yeah, you're losing 20% of the customer base next year, and by the way, the major reason is bad customer service, not bad. I may or I may not base my decision on that. Unfortunately, even if I do, I will have to change some business problems, which is difficult and political and whatever, and at the end, nothing really happens. So on the right side, and sorry for the small font, but on the right side, you will see something which we call prediction-based actions, and since prediction-based actions is the longest word in the world, we say or call them predictions. What's the idea behind that? If you know those millions of micro predictions, you could decide for every single customer. You could decide for every single event. You could decide for this millisecond of sensor data coming from your machine and make a prediction this machine is going to break within the next 5 seconds if you're not stopping doing something specific. You could do all those kind of things. And that, if you aggregate all those small predictions, is really bringing the huge value. It's not the insight alone. So that's what predictive analytics is about. Now, what is the problem? And really, I could actually, Oscar and I should do a tech team. We should work together. I've never met this guy before, so I don't even know him. I didn't say even hello, and now he's gone. But Oscar showed us another thing which was very interesting. Oscar showed the world map with all the locations of his firm. And they have a lot of people here in the United States. But then they had 2 locations, one in Mexico, the other one in Argentina, if I remember correctly, only for data scientists. Okay. So that's an interesting approach. So we're talking about science now. Why? Predictive analytics is complex. A lot of statistics, a little bit of programming, this and that. Difficult. Hadoop, sorry guys, but it is true, still is sort of complex. It's not really easy to work with this. It's not standardized in whatever way you would like to think about that. It's still a complex world. If you bring both things together, it's even worse. So now there is the new proposed, well, actually it's proposed since 5 years, but still, it's this solution. Let's create more data scientists. Let's invent a new category of employee, the data scientist, who magically can solve all those problems. How is that possible? Well, the data scientist, he is actually a strange beast. A data scientist is a hardcore programmer, of course with a PhD in statistics, and also he understands every business problem in the world. Great. By the way, whoever is in this room with this mixture of skills, please come to me. We will hire you for a lot of salary. So it's a rare skill mix. If you find those people, cool. But the problem is, those people really, because they have this rare skill mix, they are actually really good people. They have a lot of talent. They have a lot of brains. Great. But we're using them for the wrong type of task. Reality is, if you're a data scientist and you would like to create all those new cool algorithms to make predictions and do all those kind of things, reality is you're not. Reality is you're spending 95% of your time on data integration, data transformation, ETL-like processes, creating some nice visualizations, and struggling with understanding what the business people actually would like you to produce. So that's the reality. So there's a good reason why we have a shortage. And there's this famous McKinsey report, I don't know, until 2018, we will have like at least 2 million data scientists, or not enough data scientists alone in the United States. So what can be the solution? Can we really go out there and say, okay, dear universities, colleges, please produce more of them? Well, if possible, please go ahead. We will need more of them. But we can't, and we should stop thinking about them really solving all those more standard problems. So what could be the solution for that? Well, actually pretty easy. Actually, the idea would be, let's not rely on this new strange breed of creatures, which are really rarely, so they are hard to find. I heard they're existing. I never saw one. We call them unicorns. So let's not fully depend on those guys. And oh yeah, the first data scientist is going. I'm sorry. So let's not fully rely on those guys. You need them. They are part of the team, yeah, but they are part of a team. We need really to understand that the line of business managers need to be part of this team for defining the business problem, for saying, oh yeah, that is really solving my problem or not. We need to understand that actually there are 20 times more business analysts out there than data scientists. And they are used to use standard BI platforms, ETL platforms like Informatica or whatever, you name it. They're used to do those kind of things, but they are not programmers, and they never wanted to be programmers. So let's maybe think of how can we empower those people to create those predictive analytics solutions instead of hiring data scientists for standard tasks. So we have those business analysts. We might have a data scientist for creating the new algorithm. Cool. And of course, IT is involved. They usually own the data, let's face it. So it is really a collaborative team, and we have to empower them. So RapidMiner enters the stage. That was really like a 12-minute introduction just for doing a little bit of marketing. So RapidMiner enters the stage. RapidMiner, and you will see a screenshot in a second, is really about empowering those collaborative teams with different backgrounds, to put the business analyst in the driver's seat, to make you more efficient. And I promised you I'm going to talk about time. So the idea really is, and you will see RapidMiner, there's not so much programming involved, actually none. We really hide a lot of statistics, basically everything. And we let you focus on really creating the process, the workflow for really solving the problem you would like to solve. And then there's our partner, Hadoop. As you can guess, RapidMiner plus Hadoop, okay, that's the idea. And this really allows you to take those processes and execute them on Hadoop clusters. So not just accessing the data in the Hadoop cluster, but executing the process where the data lives. So that's RapidMiner. So that's just a screenshot of the user interface. You can see there is basically a process. You're loading the data, you're doing some data transformation steps, you create some predictive model. Whenever you see a green box, that's something predictive. Okay? So that's how it looks like. Well, as I said, no programming involved. You can add R scripts, you can add whatever, Python, MATLAB, you can do all those kind of things. So make your data scientists in the team happy, but let other people create those standard processes. So that's the whole idea. And then there's Hadoop. And the idea for Hadoop really is, let's now use this easy-to-use interface, and whatever you create there, you can then execute in memory. That was usually the RapidMiner default, which is the fastest, but it doesn't really scale well. You can execute the same process in your database, which is fine, and you can scale higher, but unfortunately it's pretty slow. Or, thanks to Hadoop, you can execute this on your Hadoop cluster. So, well, those are the supported distributions. Well, so you just know it's pretty much agnostic towards the actual Hadoop distribution. And the idea really is you're sitting on either on your client, creating those workflows, and just push this workflow on the Hadoop cluster, or you could use the RapidMiner server to deploy this process there, and then it gets executed there. The advantage of the latter one, just to close the loop to the beginning, is whenever you push a process to our server, you can transform this process, you just have seen one, this process into a web service. And this web service then can be integrated into the rest of your IT infrastructure. Meaning, think about those predictions, meaning that whenever you would like to predict, act automatically, for example, tell your account executives, those are the 100 people you're going to lose if you're not acting now, give them a call, give them 3% incentive, give them 10, do something, you're going to lose those customers. Those web servers are integrated, for example, directly in the CRM system, Siebel, Salesforce, whatever, you name it. So let's go through an example. And again, Oscar, really unbelievable because I never talked to him. He was talking about customer segmentation all the time, which is, well, an area where you usually would use some form of unsupervised machine learning, which is in the huge bucket of predictive analytics, data mining, whatever you call it, advanced analytics as of today. So we have some customer segmentation. So look at this, and you might know that, and that's the next time I'm talking about time. Oscar here said not exactly, but he gave me sort of a feeling, yeah, well, there was a lot of manual tasks involved. We created all the stuff, the schema on our Hadoop clusters, basically. We had to store all the data. We had to integrate this. Well, this now takes 3 hours, not the creation of those programs or processes, but actually the execution of that, instead of 3 days. So I assume they had like 15 terabytes per month. I heard something about 150 million people with a lot of transactions, the market basket and everything. So yeah, that's all integrated about all the Latinos in their database. Okay, good. So why not? So they're creating the schema, they're creating a lot of tables, they're doing all those kind of things. Then they write a lot of HiveQL or whatever queries on this data. They might create some pig scripts on that. They might really do something. In our example here, we would really like to segment users, in this case not on their buying behavior, but how they are using a certain service. Let's say just something in the web. Let's say Uber. I don't know why. Just the first thing which came to my mind. So you know how they're using this. You have all the log information about those people. Where are they? When did they collected a cab or a private cab? What are those people doing? So next thing is you have all those service logs finally integrated. Now you're aggregating information. You're doing all kinds of, well, relatively traditional analytics based on that. But you have to implement this information. How often per week is a customer driving? What is the average distance? Blah, 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 blah. You're creating all those attributes describing your customers. OK, next step. You now implement and execute a custom MapReduce job just to convert this data into something which can be used by a Hadoop-based machine learning framework. Mahout, I never know actually, but yeah, this one. So you have to do this. Next step, you run this whole thing. You're setting the parameters, you're running the algorithm, the segmentation. After some time, you will get some results. Next step, you write another job to get the results out of there. And to actually make use of that, and you have to export this whole thing, the segmentation, what customers in what segment, into a different format, because it might be that you have to write this into a file, a database for whatever type of campaign selection, whatever you want to use this for. It's a lot of work. And unfortunately, it's a lot of manual work, and there's a lot of coding involved, and that really takes a lot of time. And exactly the same work now on RapidMiner with Hadoop. So you're basically creating this workflow. It's like standing in front of a whiteboard, drawing all those lines. Like, OK, we take the data here, we do some aggregation here, we filter this, blah, 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 blah. So that's the next step. Done. That takes, I would say, about 1 minute. Well, let's say 5. Anyway. And then, like in standing in the front of the whiteboard, everybody in this collaborative team is looking at that and says, oh, interesting, look at that. I think that solves my problem. Would be good if you could just press an execute button and this process would be executed. Ah, yeah, wait a second. That's possible. So and then this whole thing is running on your Hadoop cluster. Fine. Why is that a good idea? I could make a small, not game with you, but I could ask you a question. What is the square root of 4? 2, I know that you know, but you could play with me, please, come on. So 2, you know that. I could ask you for the square root of 9, and you would say, oh yeah, sure, I know that as well, that's 3. So now let's make it a little bit more interesting before you really start asking yourself, OK, yeah, it's late in the day. Is Ingo really completely crazy or what? So I'm going to ask you now, you know the square root of 4, you know the square root of 9. What is the square root of 7? Oh, that's a little bit more difficult. Why is that actually difficult? First thing is, you know 4, which is 2, and 9, which is 3. You might thinking like, okay, 7 is between 4 and 9, so let's assume the results between 2 and 3. Good first step. You also realize that 7 is closer to 9 than to 4, so probably the result is closer to 3 than to 2. You're saying 2.6. By the way, good guess is I think it's 2.61, whatever. So you're coming up with the solution, you're approximating the solution based on previous knowledge. By the way, what you just did in your brain was predictive analytics. You based your decision on something you knew from before. So we have 4, 9, and 7. Next question, what is the square root of 497? Yeah. So what is the square root of 497? Ingo was asking strange questions. Wait a second. 22.3. How much? 22.3. Pretty good. Did you use your cell phone? No. You're just good in mathematics. Very good. The point is, I'm pretty sure most people now say 22.3. I don't believe that. And now they're taking out their cell phone. This guy is right. Or not. I don't actually know, but it's about this. The point is, you're relying on the calculator of Apple or whatever Android phone you're using or whatever app you're using. You're relying that those people are able to create a square root function calculation. You would never, ever come up with the idea, oh yeah, let's sit down, use R, Python, or whatever programming language you might just happen to know, and implement the square root function calculation yourself. Oh yeah, there was this Newton algorithm for square root function. Maybe I could implement this. Are you crazy? Nobody would do this. So why on earth is anybody believing that for something like predictive analytics or clustering or segmentation, you would have to do that? You don't. Those algorithms sometimes are decades old. Just use them like pressing on the button on your calculator, nothing more. So you have a lot of data access, blah, 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 marketing here. So you will see you could easily access those data files. You can recombine those things. You could build all those processes in RapidMiner and just, well, run your predictive analytics without the need of really understanding how all those single algorithms work. So those are things which are supported. So in case you would like to say, oh, that's cool, let's go ahead and work with that, sure. There's a trial. Feel free to reach out to us. It's a selection, it's actually not everything, but it's a selection of algorithms and ETL steps which are supported. So that's basically for, I would say, 90–95% of all predictive analytics tasks, really a pretty good set of things. And you could do a lot of stuff already with those basic building blocks you can then recombine. I'm sort of skipping this slide simply because I'm not going to bore you to death with information about other companies here. But it's interesting to see that actually even small companies have large data, as we all can imagine. So for me, one of the most amazing examples always is Prezi, which I really would have liked to use today. In case you don't know, this is like a web-based, very interactive zooming and panning presentation tool, which makes, in my opinion, a little bit more exciting presentations than PowerPoint slides. Well, anyway, so Prezi, originally from Budapest in Hungary, they have probably by now a little bit more employees, maybe 200, I don't know. So actually not that large, but they have 27 million users. And whenever you create something with Prezi, whenever you're on their website, whatever you're doing, they are logging this information. I would do the same thing. So even in their situation, they have really a lot of data, and they're doing things like A/B testing, they're doing things like customer segmentation, basically an example similar to what we have just seen. And instead of really sitting down there for 6 months, going there with a team of 10 data scientists, going down to the basement and let them work on that, really you can create something like that within a day. So that's basically how they are using this. So I promised I will talk about time 3 times. I talked about time 2 times. So this is the last topic here, which is really for different engines. And I'm getting this question a lot. So Ingo, hey, that's great. RapidMiner supports in memory, in database, in Hadoop. So when shall I use what? So the first answer I'm giving, you don't have to care, because really you can basically in the same process switch the context. You could do some things in the Hadoop context. Then you can switch and feed the information back to in-memory, where you build the model, which is faster. And then you go into a database context and apply the model there, do your scoring there. So it's supported, so you don't really need to worry. But still, people ask the same question over and over again. Yeah, but where should I store the data? Maybe it's better to do this in database, in Hadoop, whatever. So when it comes to predictive analytics, and only to predictive analytics, I have no clue about the rest of the world, but I know our field pretty well. When it comes to predictive analytics, we did a lot of experiments, tests, and everything for those different engines for different data set sizes. And well, without going into all the details here, just as a sort of a takeaway, if you have less than 100 million data points, we did most experiments between 20 and 50 attributes columns, so it depends. If you have more columns, then the number of data points usually is smaller. Usually our recommendation is, by all means, please do those things in memory. Well, you will need a decent server. You will need a lot of memory for that, but actually this investment usually is faster, smaller, easier than going there and setting up a whatever 20, 50, 100 node Hadoop cluster just for being able to do that. Although the computation will be similar, the runtime will be similar in some sense, if it's still running in memory, actually, I've never seen a Hadoop cluster where it was faster than, simply to do all the overhead. It's really a matter of money, basically. So if you can do this in memory, do that. But then you will reach the next level, which is up to about 500 million data points, where usually we say, well, if your data is already living in a standard database, use the database for that. Don't set up a Hadoop cluster just for that. If you have one, great, go ahead and use it. But before, doesn't really make that much sense. And everything beyond, there's no question. Currently, there's no other solution than running on Hadoop cluster. So here you will see what I mean. So this blue line here is for in-memory. Sorry, it's pretty small, but anyway, I'm explaining to you. So this one is for in-memory. Well, it stops here. Why? Yeah, guess why? Because we can't really work with the segmentation on more than 100 million data points, even on a decent server here. So as you can see, this is runtimes in seconds on the y-axis. In-memory really is the fastest by far. So even on larger Hadoop clusters, it was really difficult to beat the in-memory execution. This is a question of the algorithms. This is a question of overhead. This will change over time. Every single Hadoop generation, every technology on top of that will change those things. But as of today, this is what we have observed. This orange line is for in-database. And actually for database set sizes, in this case for less than 75 million, for this particular data set, for this particular algorithm, which is a naive base, which is less naive than it sounds, but still is relatively easy. So for this particular setting, actually, in database setting would have been much faster than in a Hadoop setting. It starts really prohibitively slow on a small data set. The overhead is just too large. So it doesn't really make a lot of sense for even starting using Hadoop for data sets of this size. In that case, our recommendation would be still use RapidMiner, extract the data. If it fits in memory, run the execution there. Another one is on the number of nodes, which is, we have here like 10, 30, 100 nodes, whatever, on those three lines. Don't ask me what happened at the 10 nodes on the left side. So I don't know, experiments. Sometimes things go wrong. But you can see, of course, it pays off to invest there. But still, even for the 100 node cluster, we have not been able to beat in memory on the smaller data sets for up to 50 or even the 100 million data points. So it's a huge investment if you think about that. Just, am I at the right conference for saying some stuff like that? I'm not sure. But you have to think about that. Use the right technology for whatever problem you have, but don't be dogmatic on that. That would be my piece of advice on that. So anyway, okay, so we talked about predictive analytics on Hadoop for everyone. So if you never did not take anything else with you, then the statement, well, you could do all those things, creating the tables, writing the jobs, creating the scripts. You could do all those things. That's great. If you can do this, go ahead. But don't expect that everybody can do them. So if you want to have something which is easier, where you really break down the silos, where you can mix and match in memory, in database, in Hadoop, whatever, and you see the overall workflow, which is understandable, where you can collaborate with others, RapidMiner might be a good solution for you. Runtimes. Good. By now I can really say it doesn't really matter that much how much data you have, because really it runs on basically everything. But unfortunately, it comes at a price, and the price is larger runtimes. And it also comes with a second price. Just on a side note, not every single algorithm can be parallelized. So what works with a naive base, a decision trees, a k-means, for those of you who know those technologies, doesn't work for a support vector machine. It hardly works for a neural network. So there are techniques which are really, well, working very well on a Hadoop cluster and some which don't. So know what you want to use and then pick the right one. So I already gave a couple of recommendations in terms of data set sizes. So the rule of thumb we are currently using is less than 100, invest in memory. More than 100, start thinking about what you have. If you have a Hadoop cluster in place, go with this. If not, in database might fill the gap until you're really getting into a region where this is really large. Okay, so that's from my side. I'm happy to answer any questions if there are any. Thanks. Yeah, please.
Can we go to slide 20?
This one?
Yeah. So can't you do distributed memory for the in-memory so you can solve larger problems?
Than the 100 million one? Well, if you invest into memory, I think this was running on a terabyte server.
The same distributed memory so you can go on.
Oh, yeah, yeah. Oh, good point. Actually, we have an integration with Terracotta, just as an example, to use the distributed memory for that. It then would work. It's getting really slow, but it works. Yeah, it's possible. Please.
So, is size of data only metric to scale out? Are you running into situation that computation is the bottleneck, you have to scale out because of CPU?
Good point. Actually, yes, it's more than memory because we have those two phases in predictive modeling. The first phase is about the model building. And usually labeled data which you need for creating the model is scarce. You really don't have like that much labeled data. Sometimes you have, but in many cases you don't have this. So the model building is actually less of a problem, and it's really depending on the scheme, like support vector machines as an example, runtime is the limiting factor. So you don't really have that much labeled data, but even if you would have this, the runtime is the killer. It's not so much actually, well, depending on the algorithm, but in many cases it's not the memory. But for the scoring phase, where runtime usually is fast, so it's doable in linear time, basically. The problem is that you really score a lot of data points. In many cases, really, you have to be fast in real time, as an example. We have experiments for that as well. I didn't show them today, but you can really see, okay, that is sometimes, by the way, is a problem, because if you really, for the scoring process, and you want to do this batch-wise, perfect. It's pretty fast, it's good, it works very well. But if you want to do this for a single node, I would not execute this process on the Hadoop cluster then again, because the overhead is killing you. And if you're in a predictive maintenance setting or in a manufacturing process and you have to react fast, you couldn't react fast enough. If the prediction takes 5 seconds and you have to shut down the machine now, it's not working. So for everything in a real-time environment, sometimes it is problematic. And in that case, as we say, build the model in the Hadoop cluster and then build the web service basically running on the server and do this execution of the scoring in memory then. Oh, yeah, there's an extension for RapidMiner. Maybe, I don't know if you have more later insights, Zoltan, but there's actually an extension for RapidMiner where you have certain algorithms which are running on a GPU, and they are much faster, yeah. Then memory, again, is becoming the issue. If you can now mix and match those two things, like having distributed and set up, we don't really have that yet, but yeah, there are extensions for the platform for that as well.
So if I need to follow up on that, who do I talk to?
You could call me, Zoltan, somebody from RapidMiner, all is fine. Sure. Other questions? In that case, have fun tonight and good party. See you.